Newton's third law, or the law of action and reaction, is at work around us at every moment. This law says that for every action, there is an equal and opposite reaction. So when we're walking down the street, as our foot pushes against the ground, that's the action. The ground pushes back with the same force on our foot so we can take a step. That's the reaction. If the ground were slippery and there was no friction, we wouldn't be able to walk because the ground wouldn't push back on us. Or, for example, in a car crash, if you hit a wall at speed, you exert a force on the wall, and at that very moment, the wall exerts the same force back on the car, which is why the car crumples. If you're lucky and the airbag deploys, you hit the airbag instead of the windshield. If you look at Newton's third law philosophically, it says that nothing goes unanswered, even in physics. But that's just the beginning of the story, because the laws of physics not only work in your classroom and in experiments, but they also shape our lives and destinies. Today, we want to look at some of the most interesting of these laws of physics together. Make sure to watch the video to the end, because each of these laws is more fascinating than the last. Imagine you're riding a bike down a lush green hill, the wind whistling in your ears, your heart pounding, and you feel like the world is at your feet. Right here, Newton's first law, called inertia, comes into play. It says that if something is moving, it will keep moving unless an external force causes it to stop or change direction. So your bike will keep going unless an external force like the brakes or a collision acts on it. Now imagine a small rock suddenly appears in front of you. As your front wheel hits the rock, the bike jumps, but according to the first law, your body still wants to keep moving straight, so you get separated from the bike and, like Superman, you go flying forward and crash to the ground. Jokes aside, let me add that among the external forces that can affect motion are friction and air resistance. These are important external forces that gradually slow down and eventually stop motion. Of course, when you're going downhill on a bike, gravity is also at work because the weight of the bike and your own weight pull you down the hill due to Earth's gravity. So, even though air resistance and the friction between the bike tires and the ground still exist, gravity keeps pulling you down. Now, let's get to Newton's second law, the famous F equals ma. Let me illustrate this law with a simple example. Imagine you want to lift a bucket off the ground. If the bucket is empty, you can do it easily and quickly. But if the bucket is full of water, you have to use a lot more force to lift it, and your movement is much slower. That's exactly what Newton's second law says. When a force is applied to an object, the object's acceleration is proportional to the force applied and inversely proportional to its mass. That's why heavier things accelerate less. So, if you want to get a heavy truck moving as fast as a light car, you have to give it more gas. Philosophically, Newton's second law is like saying nothing comes without effort and force. So, if you want big results, you have to work harder. Now, let's get to that moment of awareness. That moment when a scientific or philosophical truth changes the way we see life. Have you ever felt like your days are just repeating? Your relationships have lost their excitement, and all your decisions are made out of habit? Like you're stuck in a boring, aimless cycle? This is where the second law of thermodynamics comes in. What does that mean? Let me explain. To understand the second law of thermodynamics, you first need to know what entropy is. Entropy is the amount of disorder or chaos in a system, a kind of measure of uncertainty. The second law of thermodynamics says that any closed system tends toward more disorder or higher entropy. We know this law originally applies to physical systems like gas molecules in a closed room, but the concept can be applied to many things. For example, if we don't bring energy and order into our lives, don't set goals, don't invest time in our relationships, and don't make conscious decisions. Over time, disorder increases, repetition, monotony, mental chaos, and even depression take over our lives. Just like what happens to molecules in physics, the same thing happens in our minds and lives. Interestingly, this law also applies to closed political systems. In a dictatorship where no new information comes in and opposition is suppressed, social entropy rises. Distrust, corruption, inefficiency, underground unrest, and even the collapse of the system can occur. In fact, many sociologists like Nicholas Luhmann or Stephen Lukes have used these scientific concepts to explain why closed systems eventually fall apart. They can't cope with increasing disorder. But Planck's quantum law is one of those mind-blowing parts of physics that can really blow your mind. Have you ever tried to turn on a device, but no matter how many times you press the button, it doesn't turn on? And then suddenly, with one more little push, it works? Keep that in mind as I explain Planck's quantum law, which is shown by the formula E equals h nu. In the early 20th century, a German named Max Planck said that energy isn't a continuous, endless flow, but more like coins. It can only be transferred in specific tiny amounts. He called each of these tiny packets a quantum, and the plural is quanta. For example, imagine you go to a vending machine in New York, and each soda costs exactly $1. You have 4 quarters, 25-cent coins. You can't buy a soda with just 3 quarters because the machine won't accept it. You have to pay exactly $1. Energy works the same way. It can't be any random amount, only certain specific amounts are accepted in steps. In other words, unlike what people used to think, energy isn't continuous, but is transferred in discrete packets. These tiny packets of energy are represented by a very small number you see on the screen, called Planck's constant, or h. So, everything, even sunlight, is transferred in quanta or tiny packets of energy. Now, what does this have to do with life? You might think that reading one page of a book, taking one step, or sending a thank you message is small and insignificant. But in reality, it's these little things that add up and shape your life, just like quanta. Sometimes, a system builds up energy for a while and nothing happens. But then suddenly, with one more push, everything changes. Sometimes we work for years and nothing changes. But then suddenly, a call, an opportunity, or a moment changes everything. That's the power of quantum change, or the leap from one state to another. So, the key is to keep going until that leap happens. Now that we've learned a few laws of physics, you should know that some say it's better to call them models for explaining nature's behavior, because physicists observe things, like Newton saw an apple fall from a tree, and then they create a model or formula to explain and predict that behavior. But in reality, a law of physics is just a kind of mathematical or mental model that tries to explain and predict what we see. For example, if we say everyone who runs in the street gets tired, that becomes a law of fatigue. But if someone is a professional athlete and doesn't get tired, then the model isn't exact. It's just an approximation based on one person's experience and observation. Reality might not be the same for everyone. It depends on who's looking and from what perspective. The Chinese saying about the Rashomon effect says the same thing. If several people witness an event, each might have a different interpretation. It's the same in physics. One person might look at things from a classical Newtonian perspective, another from a quantum perspective, and another from general relativity. Each understands a part of reality, but none of them alone is enough. Personally, I think physics is an amazing combination of science, philosophy, and even art, which helps us understand the secrets of the universe. In other words, physics isn't just formulas, it's a universal language. Newton, Einstein, Hawking, and even people like Mirzakhani, whose mathematics was like a map for physicists, each looked at this language in their own way, like artists painting a picture with their own special tools. Now, you write your opinion in the comments. Which law of physics do you find most fascinating? The lesson this video gives us is that the laws of physics are, in a way, the story of our lives. They govern everything from our first steps to the motion of distant planets. And when we realize that behind every equation there's a why, we understand that science is the most beautiful story there is.